Yesterday, we discussed Avogadro's number. And we went through this, folks, and we looked at this slide and said, okay, here is 1 mole of sucrose. 1 mole of sucrose weighed 342.3 grams, and this was Avogadro's number of sucrose molecules. Okay, what was Avogadro's number again? 6, how about this? 6.022 times 10 to the 23rd. Now, we said that when we were dealing with Avogadro's number, there are 3 ways that we can label them. You might want to write this down in your notes. It's not in your notes. You might want to write this down. Right here, 1 mole of carbon. Carbon is an individual atom. So that's the first way. If it's an individual element by itself, we label it atoms. So this would be Avogadro's number of carbon atoms. 6.022 times 10 to the 23rd carbon atoms. Because that is 1 mole of carbon atoms right here. How much does 1 mole of carbon atoms weigh? 12 grams. We just talked about sucrose to start this off. Here's 1 mole of sucrose. Sucrose is covalently bonded together. So, when I'm talking about Avogadro's number, I label something that is covalently bonded as molecules. So, right here in this measuring dish, I have 6.022 times 10 to the 23rd molecules of sucrose. That is equal to 1 mole of sucrose, and it weighs what? 342.3 grams. The third way to label Avogadro's number of particles is if we have ionic bonding. Sodium chloride is ionic bonding. It is a salt. So, when I am dealing with a salt, I label Avogadro's number as formula units. So, right here in the measuring dish is 1 mole of sodium chloride. So I would say that is Avogadro's number 6.022 times 10 to the 23rd formula units of sodium chloride. Now, we haven't talked about this one yet. So how am I going to determine, right here, how am I going to determine whether I am labeling this an atom, a molecule, or a formula unit? What do I need to look for? Huh? What kind of bonding? Good, Michael. What kind of bonding? First of all, is this a single element? So can we take out atoms? Absolutely. So it's either got to be a molecule or a formula unit. What type of bonding do I have occurring right here? Huh? I hear covalent, I hear ionic. It's got to be one of the two, right? Can it be both? Can it be both? Think back to bonding. Can't remember back to bonding? Where would I find copper at? It's a metal, right? It's a metal. So anytime we have a metal, what type of bonding are we dealing with? Can't hear you. Ionic bonding. Okay? So, to go back and answer the question, could we have ionic and covalent? Yes, because this is a polyatomic ion, sulfate. Polyatomic ions are covalently bonded, but nonetheless they are ions. So now we know what type of bonding we have. So how are we going to label Avogadro's number of these copper 2 sulfates? What would we call it? Come on, people. You've got 3 choices. We already said it can't be atoms, right? So what are the other 2 choices? What are the 2 choices, Shelby? Formula units or molecules? Which is this? Formula units, why? Because it's ionic. So this would be 6.022 times 10 to the 23rd formula units of copper 2 sulfate. Now let's talk about the molar mass. What is the molar mass? It is the mass of 1 mole of a pure substance. Molar masses are usually written using the units grams per mole. So basically, the molar mass is the mass of a mole. Now let's say, on my periodic table, take out your periodic tables, we're going to be using those again today. Probably going to want your calculator out also. If I have an individual element, the molar mass is simply the atomic weight of that element. I look at lithium. Find lithium on your periodic table. It's an alkali metal. What is the atomic weight of lithium according to your periodic table? 6.941. Correct? Look up mercury. Mercury has the atomic number of 80. Okay, it's a transition metal. What does your periodic table say the atomic weight of mercury is? 200.59. So, if I have 1 mole of mercury, how much will that weigh? 200.59 grams. If I have 1 mole of lithium, how much will it weigh? 6.941 grams. So where do we determine the molar masses? By looking at our atomic weights on our periodic table. Not too tough, right? Didn't we do water yesterday? We added up 2 hydrogens and 1 oxygen on the board yesterday. So when we added those 3 things together, we got a mass. That was the mass of 1 mole, the molar mass. We're going to start off real easy. What is the molar mass of sodium chloride? The first thing you need to do, as you're typing this into your Chromebook, is, what is the formula of sodium chloride? NaCl, Graham says, right? Would everybody agree? So, what is the mass of sodium? How about 22.99? I've rounded that, okay? I've rounded that to the, what is that, 10/100ths? Okay? Do you have to round it? No. No. On WebAssign, folks, on WebAssign, you're going to use the values on the periodic table, and then you're going to use those significant figure-wise based on addition and subtraction. So you might want to, before you do your WebAssign tonight or today, you might want to look and review significant figures when I'm doing addition and subtraction from beginning of the year. Now, sodium 22.99. What's chlorine? 35.453. Now, what would it equal if I would add those 2 values together? 22.9 plus 40, or excuse me, check, plus 35.45 will give me 58.44 grams per mole. So what is the molar mass of sodium chloride? 58.44 grams per mole. That wasn't too tough, was it? Now let me ask you this. What would have happened if I would have messed up and said that it was NaCl2? Would that have affected my molar mass? If I would have wrote this wrong, right here, and said there were 2 chlorines, my molar mass down here would be 35.45 grams too much, wouldn't it? Can you see how, if we can't write the formula, we're going to struggle with this stuff? We've got to be able to write formulas, folks. So let's start out here. Here's another one. What is the molar mass of dinitrogen pentoxide? Very first thing we need to do is we need to write what the formula of dinitrogen pentoxide is. Nice and loud, actually. So now I go through. I say, okay, I've got how many nitrogens? How many nitrogens do I have? 2. Each one of them weighs what? 14.00. So that would be how much? 28. I've got 14.01. Did I round that wrong? No, I didn't. Okay. 14.01 times 2, I have 28.02. How many oxygens? 5. Each oxygen weighs what? 16.00, right? If I round it to 2 spots like I have been. So 16 times 5 is going to give me 80. I add together 80 and 28.02, and that gives me 108.02 grams per mole. Uh-oh. Probably going to need your ion sheet to name this one, aren't you? So take out your ion sheet. Doggone it. And you know what? I love throwing these on there, folks. I love throwing things on here because this tells me how good you know your nomenclature. I don't think the molar mass is the hard part. I think the nomenclature is the hard part, and I've been telling you that. Now, I am dealing with a dichromic acid. Dichromic acid. So if I'm dealing with an acid, I immediately go back to 3 rules for acids, right? Rule number 1, rule number 2, rule number 3. Which of the 3 acid rules am I dealing with here? Rule number 3. Rule number 3 says what? The ending, excellent, Chloe, the ending with IC, but it does not have hydro. No hydro IC tells me that that's an ATE ending. So what polyatomic ion am I looking for? Dichromate. What is dichromate? Cr2O7, correct? What's the charge? -2. So how many hydrogens do I need to go with that? 2 of them. So what am I going to write for my formula of dichromic acid? H2Cr2O7. Now, isn't it kind of important to be able to do that? To know how many I've got to multiply each one by? So now, folks, and I'm telling you this, I've done this many, many years. If I'm writing out my molecular mass, I do it exactly as I have up here on the board. I break it down individually, and I say, okay, hydrogen. How many hydrogens do I have? I have 2 of them. Each hydrogen is 1.01, so that gives me 2.02. Chromium was one I really am not familiar with. 51. Can't read my periodic table, I'm getting old. 996, so that's going to be, if I'm rounding it to 2 spots, it's going to be 52.00. How many are there? 2 of them. Oxygen, 15.9994. If I'm rounding it to the 100, like I've been doing up here, I'm going to round it to 16. How many oxygens are there? 7 of those. 16 times 7 is 112. Once I put it all together, 2.02 plus 1.04 plus 112.00, I come up with the value of 218.2 grams per mole. You tell me right now, folks, you give me a thumbs up, or I've got one more example. You tell me, do I need to work that other example? Yeah, Carly? I rounded at the very end, okay? WebAssign follows the significant digits. I'll probably change this, well, maybe I won't, okay? But it follows the exact number of the periodic table. So you have to look at the very last number and where you need to round. So make sure you do that, or it'll count you wrong. We got thumbs up, we okay? We don't need the other example? Okay, you've got roughly 10 minutes. Get on WebAssign, the new one is up. It went active this morning. Get on WebAssign and try these out. That way, if you have a question, you can ask me before you leave here today.